Hello teachers, our group is JH407A. In this video, we will be showing you our STEAM project, how we came up with the idea for this product, and how it can address the needs of our teaching staff.
Our product is called the Ball Sorter. Our product is designed to help the PE teachers of NJ sort the balls in the PE storeroom easier. We chose teachers to be our stakeholders as we feel like we should give back to them for helping us in school. We interviewed many teachers about what problems they face in school, and we finally came down to choosing to help the PE teachers regarding the unkeptness of the PE storeroom. Many students do not put the balls back in the correct spots, and this makes it harder for teachers and students alike to find the type of the ball they need.
The reason why we choose this issue is because it also directly affects us, as we are also using the PE storeroom, and therefore solving this problem would be beneficial to the student body as well. Hence, our project will focus on how students do not put the different types of balls back to their designated spots and solving that problem.
Now we will be explaining how we came up with the final solution. Firstly, we thought about the sorting and classification of balls problem from a mathematical perspective. Classification methods aim to identify a specific category among a set of numerous categories. We can apply the method on our prototype to classify the different balls according to some physical factors, such as weight or dimension of the balls. In our experiment, we chose to use the diameter of the balls to sort them.
We decided on using the RAM method as that seems like the most feasible for us to build. The RAM method is basically rolling a ball between two rams as the distance between the rams get larger. This causes the balls to be sorted based on size. Because the application of the ramp is related to gravitational force, we chose the diameter as our classification factor.
Our prototype was made with cardboard and PVC boards. These materials were chosen for the inexpensive price and the accessibility. They are rather cheap and easy to find, hence there was a good fit for our prototype. Additionally, the cardboard and PVC board are easily detachable. Our group did a lot of improvements when we were making the prototype, so the property of being easily detachable was highly important.
Firstly, this is the front view of our prototype. As you can see, the ramp is elevated at a 15 degrees angle to ensure the highest success. After doing some research, we found out that the angle is proportional to the speed of the ball when it's running down the ramp, and 15 degrees was the optimum angle. We have also decided to put barriers on the sides of the ramp. This is to prevent the balls from rolling out. Some of the smaller balls may also continue to roll past their designated chambers due to their inertia. To solve this problem, we decided to add grooves along the barriers. The balls will hit this groove and thus stop rolling and fall into their designated chambers. As the balls roll down the ramp, they will be dropped down into the chambers below.
The chambers represent the respective spaces that the balls should be in the PE room. The smaller balls are dropped in the first chambers and the bigger balls fall into the chambers later.
This is the back view of our prototype. We decided to make it clear because it is easier to see what is going on inside the prototype.
Now we will be showing you the full process of the sorting of the balls. As you can see, the bigger ball dropped into the chamber towards the back of the ramp, while the smaller ball dropped into the chamber closer to where it first dropped on the ramp.
Now that you know how this works, we will then explain how we can help solve the problem that PE teachers face, which is students not putting the balls back properly to their designated spots. This may be due to laziness or just not knowing where the balls should be put back to. Our product solves this problem and is very easy for all students to use. All they need to do is put the balls into the machine, and the machine will automatically sort the balls themselves. This will help keep the PE storeroom neater, as all the balls will be placed back properly and both the students and teachers will be able to find the balls they need more quickly.
Our idea is fairly feasible to build into an actual product, as the design is not very complex. The design can be easily expanded to sort a greater variety of balls with different sizes. It also doesn't require any materials that are hard to acquire. However, it isn't really as practical due to many different types of balls having similar sizes. It also requires at least 2 floors. The higher one being the place for the balls to be dropped and the lower being the PE room. where the sorted balls will be stored.
Thank you for listening to our presentation, and we hope you enjoyed it.